Hello, welcome you all to Tech Social Cloud, and I'm Anjali to get ready to embark on an exciting journey into the world of Java. Whether you are a seasoned developer or preparing for an interview or a Java enthusiastic eager to enhance your skill, this video is made just for you. We'll simulate a real interview experience with a series of carefully curated Java Stream API questions. Each question is designed to test your knowledge and understanding of this powerful feature. It will definitely help you in your upcoming Java interview. So let's get started. So the first question is, what is Stream API? Before Java 8, working with a collection usually meant using for loops, iterator or for each constructs. These were not only verbose but also lacked expressive, often causing the intent behind the code to be buried beneath the mechanism of iteration. With the growing popularity of a functional programming language and paradigms, there was an immediate need for Java to evolve. So the Stream API in Java was born out of this need, blending the functional programming paradigm within the traditional imperative Java, allowing developer to process data in a more expressive and concise manner. Java streams are powerful and flexible way to process collection of data in a functional and declarative way. Streams allow developer to express complex operations in a concise and readable way and can lead to more efficient and parallelized code. Streams are essentially a sequence of elements that can be processed in a parallel or sequentially. It can be obtained from a collection or an array using the stream or parallel methods. And once you have a stream, you can have a variety of methods to transform, filter and aggregate the data. Stream API do not store element. It is a functional operational performed using a stream, do not modify its source. So how can we create a stream? There are several ways to create a stream. So we can create it using the collection from an array, from a stream of method. Stream is containing a method of. By using of that, we can create the stream from a range of values and from a string as well, and many more exist. I hope it is clear to you. Now let's move to the next question. So the next question is, what is the difference between collection and stream? A collection and a stream are both ways to work with a sequence of element in Java, but they differ in several ways. A collection is an in-memory data structure and hold the finite number of elements. Collections can be indexed and accessed in a random order that typically provide methods for adding, removing and querying elements. A stream, on the other hand, is a sequence of elements that can be processed in a functional way without the need to store them in a memory. Streams are designed to support a parallel processing of a large data sets, and they can be created from various sources such as a collection, array, file or other data sources. Here are some key differences between collection and streams. So storage, collection store all their element in a memory, whereas stream do not necessarily store all the element in memory. Streams can work with the data from various sources and they can process data on the fly as it becomes available. Let's talk about mutability. So collection can be mutable or immutable depending on the implementation. Streams, however, are always immutable and do not allow modification of their underlying data. Now iteration, so collection can be iterated over multiple times and elements can be accessed in any order. Streams are typically consumed once and cannot be reused. Streams are evaluated lazily, meaning that intermediate operations are only performed when a terminal operation is invoked. This allows for more efficient processing of large data sets as only the necessary data is processed. Streams support parallel processing, which means that the large data can be processed in a parallel using a multiple threads or processors. In summary, collections are designed for storing and manipulating data in memory, while streams are designed for processing data in a functional, parallel and lazy way. Okay, so now let's move to the next question, which is, what are the different type of operations in stream? Stream is not a data structure itself. It is a bunch of operation applied to a source. It has basically two type of operations. First is an intermediate operation and the second is terminal operation. So intermediate operation is like these methods do not produce any result. They usually accept functional interface as a parameter and always return a new stream. Example is like filter or map, we can say. And terminal operations is like these methods produce some result like count, collect, etc. And intermediate operations are lazy. All intermediate operations will not execute without a terminal operation at the end. In a way, an intermediate operation is memorized and it is recalled as soon as a terminal operation is invoked. You can chain multiple intermediate operation and none of them will do anything until you invoke a terminal operation. And that time all of the intermediate operation that you invoked earlier operator will be invoked along with the terminal operation. Let's go through some intermediate operation like filter. It return a new string consisting of elements that match the given predicate. Map is transform each element using the provided function. Flat map is a flatten the element of each mapped into stream into a single stream. Distinct return a stream with a distinct element based on their natural order or using a provided comparator. Sorted return a stream sorted in a natural order or using a provided comparator. And p, so it perform an action for each element of the stream without modifying the element. Like if we required to print all the elements, so it will print all the elements without modifying it. Now let's move to some terminal operations. For each, perform an action for each element of the stream. Collect, transform the elements of the stream into a different from using a collector. Count, return the count of element in the stream. Any match and all match and none match. Check if any, all or no elements match the given predicate respectively. Find first or find any returns the find any element of the stream. Reduce and collect, so perform a reduction of the elements of the stream using an associative accumulation of function. Okay, so now let's move to the next question, which is what does the map function do? Why do you use it? So map function is an intermediate operation that transforms each element of the stream using a provided function. It produced a new stream consisting of the result of applying the given function to each element of the original stream. It produced a new stream consisting of the result of applying the given function to each element of the original stream. The key purpose of map is to transform data from one form to another. For example, suppose you have a list of strings representing names and you want to create a new list containing the length of these names. You can use the map function for this transformation. So in this example, map apply the length method of the string class to each element of the stream. The resulting stream contains the length of the names. Okay, great. So now let's move to the next question. So the next question is what does the filter method do and how we can use it? So filter method is an intermediate operation that is used to filter elements from a stream based on a specified condition. It takes a predicate as an argument and the element that satisfy the given predicate are retained in the resulting stream, while those that do not are discarded. Here is the general syntax for a filter method. Stream filter you can see on the screen. Now suppose you have a list of numbers and you want to create a new list containing only the even number. You can use the filter method for this purpose. So in this example, filter method apply the predicate and each element of the stream. The resulting stream contain only the element that satisfy the condition. Okay, I hope it is clear to you. Now let's go ahead with the next question, which is what is the predicate interface in Java stream? Predicate interface is a functional interface that belongs to the java.util.function package. It represents a boolean valued function of a one argument and it is often used in the context of a stream operation to define condition for filtering elements. The predicate interface is a single abstract method we can call. So in this example, the start with a predicate is a predicate that tests whether a given word start with a. The filter operation is used to return only those words from the stream that satisfy the condition specified by the start with the predicate. Okay, so now let's move to the next question, which is what is the difference between map and flat map of a stream API? This is very important question. It occurs in almost every interview of a Java, whether you have experienced or you're a fresher. So the map and flat map methods are intermediate operation of Java 8 Stream API. Map operation produce one output value for each input value, with the flat map operation produce an arbitrary number values for each input and value. Also, flat map operation is the combination of map and flatten operations. So the map method is used to transform each element in the stream using a given function. It produces a new stream where each element is the result of applying the provided function to the corresponding element of the original stream. The result is one-to-one mapping of element. A flat map method is used to flatten a stream of a collection on array into a single stream. It not only transform each elements but also flatten the resulting collections array into the single stream. It is particularly useful when dealing with the nested structure. I hope it's clear to you. Please comment if you have any question. So let's move to our last question, which is what is a parallel stream and sequential stream? When working with the stream API introduced in Java 8, streams can be produced either sequentially or in a parallelly. There are known as a sequential stream and a parallel stream respectively. So sequential stream is a default mode of stream processing. It is a sequential stream. The operations are performed in a single threaded manner, one after another. On the element of the stream, each element is processed in order and next operation is executed. Stream and a parallel stream on the other hand allow for the concurrent processing of elements using multiple threads. The stream is divided into multiple chunks and each chunk is processed by the separate thread simultaneously. Once the processing of each chunk is complete, the results are combined to produce the final result. So when we can go with the sequential or when we can go with the parallel. So use a sequential stream when the order of processing is important or when the operations are not easily parallelized. Sequential streams are often simpler to reason about, can be a more predictable, and parallel stream use when you have a large amount of data and the operation can be performed independently on a different elements. Parallel streams can offer performance improvement for computability intensive tasks, especially on a multi-core system. So let's talk about some important features. So first, maybe we can talk about thread safety. When using a parallel streams, ensure that the operation are thread safe. If shared mutable state is involved, proper synchronization may be needed. Stateless, so stream operations should ideally be stateless and not rely on shared mutable state to avoid unexpected behavior in parallel processing. And performance overhead. So while parallel streams can provide performance benefits, there is an overhead associated with the thread creation and management. For a small data set or simple operations, the overhead may outweigh the benefit. In summary, whether to use a sequential or parallel stream depend on the nature of the task, the characteristics of the data, and the desired trade-off between simplicity and performance. It is important to carefully consider these factors while choosing between sequential or parallel stream processing. So here we are done with the today's interview question. If you have any more question, need assistance with another topic, or if there is anything else I can help you with, feel free to let me know. If you found this content valuable, don't forget to hit the like button, share with your peers, and subscribe to Tech Social Cloud. For more insightful content on technical stuff, your support is greatly appreciated. Feel free to leave your comment and question down below. I'm always eager to hear your thoughts and engage in discussion. If there are a specific topic you would like to cover me in future videos, please let me know. Thank you for tuning in today. Until next time, happy learning. Bye bye.